Iran has made considerable advances in science and technology through education and training. Despite international sanctions in almost all aspects of research during the past 30 years, Iran's university population swelled from 100,000 in 1979 to 2 million in 2006. 70% of its science and engineering students are women. Iran's scientific progress is reported to be the fastest in the world. Iran has made great strides in different sectors, including aerospace, nuclear science, medical development, as well as stem cell and cloning research. Persia was a cradle of science in earlier times, contributing to medicine, mathematics, science, and philosophy. Trying to revive the golden time of Persian science, Iran's scientists now are cautiously reaching out to the world. Science in Persia. Science in Persia evolved in two main phases separated by the arrival and widespread adoption of Islam in the region. References to scientific subjects such as natural science and mathematics occur in books written in the Pahlavi languages. Ancient technology in Persia. The Khanate originated in pre-Achaemenid Persia. The oldest and largest known Khanate is in the Iranian city of Gonabad, which, after 2,700 years, still provides drinking and agricultural water to nearly 40,000 people. Persian philosophers and inventors may have created the first batteries in the Parthian or Sassanid eras. Some have suggested that the batteries may have been used medicinally. Other scientists believe the batteries were used for electroplating, transferring a thin layer of metal to another metal surface, a technique still used today and the focus of a common classroom experiment. Windwheels were developed by the Babylonians, California, 1700 BC to pump water for irrigation. In the 7th century, Persian engineers in Greater Iran developed a more advanced wind power machine, the windmill, building upon the basic model developed by the Babylonians. Mathematics. The 12th century mathematician Muhammad ibn Musa al-Khwarizmi created the logarithm table, developed algebra and expanded upon Persian and Indian arithmetic systems. His writings were translated into Latin by Gerard of Cremona under the title Algebrae al-Muqabalah. Robert A. Chester also translated it under the title Liber Algebrae al-Muqabalah. The works of Khwarizmi exercised a profound influence on the development of mathematical thought in the medieval West. Other Persian scientists included Abu Abbas Fazl Haytham, the Banu Musa brothers, Farahani, Omar ibn Farrakhan, Abu Zayd Ahmad ibn Sohail Borki, Abul Vafa Bauzjani, Abu Ja'far Khan, Bijan ibn Rostam Kouhi, Ahmad ibn Abdul Jalil Ami, Abu Nasr Iraqi, Abu Rayhan Biruna. The noted Iranian poet Hakim Omar Khayyam Naishaburi, Katan Malvazi, Masudi Ghaznavi, Khaja Nassereddin Tusi, and Ghiaseddin Jamshidi Kashani. Medicine. The practice and study of medicine in Iran has a long and prolific history. Situated at the crossroads of the East and West, Persia was often involved in developments in ancient Greek and Indian medicine. Pre- and post-Islamic Iran have been involved in medicine as well. For example, the first teaching hospital where medical students methodically practiced on patients under the supervision of physicians was the Academy of Gundishapur in the Persian Empire. Some experts go so far as to claim that, to a very large extent, the credit for the whole hospital system must be given to Persia. The idea of xenotransplantation dates to the days of Achaemenidi, as evidenced by engravings of many mythologic chimeras still present in Persepolis. Several documents still exist from which the definitions and treatments of the headache in medieval Persia can be ascertained. These documents give detailed and precise clinical information on the different types of headaches. The medieval physicians listed various signs and symptoms, apparent causes, and hygienic and dietary rules for prevention of headaches. The medieval writings are both accurate and vivid, and they provide long lists of substances used in the treatment of headaches. Many of the approaches of physicians in medieval Persia are accepted today, however, still more of them could be of use to modern medicine. In the 10th century work of Shahnameh, Ferdowsi describes a caesarean section performed on rude bear, during which a special wine agent was prepared by a Zoroastrian priest and used to produce unconsciousness for the operation. Although largely mythical in content, the passage illustrates working knowledge of anesthesia in ancient Persia. Later in the 10th century, Abu Bakr Muhammad bin Zakaria Razi is considered the founder of practical physics and the inventor of the special or net weight of matter. His student, Abu Bakr Jovini, wrote the first comprehensive medical book in the Persian language. Razi is also the inventor of alcohol. After the Islamic conquest of Iran, medicine continued to flourish with the rise of notables such as Rhazes and Haile Abbas. Albeit Baghdad was the new cosmopolitan inheritor of Sassanid Jungdishapur's medical academy, an idea of the number of medical works composed in Persian alone may be gathered from Adolf von Arndt's Zirkelkunde der Persischen Medizin, published in Leipzig in 1910. The author enumerates over 400 works in the Persian language on medicine, excluding authors such as Avicenna, who wrote in Arabic. Author-historians Meyerhoff, Casey Wood, and Hirschberg also have recorded the names of at least 80 oculists who contributed treatises on subjects related to ophthalmology from the beginning of 800 AD to the full flowering of Muslim medical literature in 1300 AD. Aside from the aforementioned, two other medical works attracted great attention in medieval Europe, namely Abu Mansur Muwaffaq's Materia Medica, written around 950 AD, and the Illustrated Anatomy of Mansur ibn Muhammad, written in 1396 AD. Modern academic medicine began in Iran when Joseph Cochrane established a medical college in Urmia in 1878. Cochrane is often credited for founding Iran's first contemporary medical college. The website of Urmia University credits Cochrane for lowering the infant mortality rate in the region, and for founding one of Iran's first modern hospitals in Urmia. Astronomy in 1000 AD, Biruni wrote an astronomical encyclopedia that discussed the possibility that the Earth might rotate around the Sun. This was before Tycho Brahe drew the first maps of the sky, using stylized animals to depict the constellations. In the 10th century, the Persian astronomer Abd al-Rahman al-Sufi cast his eyes upwards to the awning of stars overhead and was the first to record the galaxy outside our own. Gazing at the Andromeda galaxy, he called it a little cloud, an apt description of the slightly wispy appearance of our galactic neighbor. Biology chemistry Toosey believed that a body of matter is able to change but is not able to disappear entirely. He wrote, "A body of matter cannot disappear completely. It only changes its form, condition, composition, color, and other properties, and turns into a different complex or elementary matter." 500 years later, Mikhail Lomonosov and Antoine Laurent Lavoisier created the law of conservation of mass, setting down this same idea. However, it should be noted that Toosey argued for evolution within a firmly Islamic context. He did not, like Darwin, draw materialist conclusions from his theories. Moreover, unlike Darwin, he was arguing hypothetically. He did not attempt to provide empirical data for his theories. Nonetheless, his arguments, which in some ways prefigure natural selection, are still considered remarkably advanced for their time. Jabir ibn Hayyan, the famous Iranian chemist who died in 804 at Taus in Khorasan, was the father of a number of discoveries recorded in an encyclopedia and of many treatises covering 2,000 topics. And these became the Bible of European chemists of the 18th century, particularly of Lavoisier. These works had a variety of uses, including tinctures and their applications in tanning and textiles, distillations of plants and flowers, the origin of perfumes, therapeutic pharmacy, and gunpowder, a powerful military instrument possessed by Islam long before the West. Jabir ibn Hayyan is widely regarded as the founder of chemistry, inventing many of the basic processes and equipment still used by chemists today, such as distillation. Physics. Abu Ali al-Hasan ibn al-Haytham is known in the West as al-Hasan, born in 965 in Persia and dying in 1039 in Egypt. He is known as the father of optics for his writings on, and experiments with, lenses, mirrors, refraction, and reflection. He correctly stated that vision results from light that is reflected into the eye by an object, not emitted by the eye itself and reflected back. As Aristotle believed, he solved the problem of finding the locus of points on a spherical mirror from which light will be reflected to an observer. From his studies of refraction, he determined that the atmosphere has a definite height and that twilight is caused by refraction of solar radiation from beneath the horizon. Biruni was the first scientist to formally propose that the speed of light is finite, before Galileo tried to experimentally prove this. Kamal al-Din al-Khwarizmi, born in Tabriz, Iran, is known for giving the first mathematically satisfactory explanation of the rainbow, and an explication of the nature of colors that reformed the theory of Ibn al-Haytham. Al-Khwarizmi also proposed a model where the ray of light from the sun was refracted twice by a water droplet. One or more reflections occurring between the two refractions. He verified this through extensive experimentation using a transparent sphere filled with water and a camera obscura.